Hello everyone, you're welcome back to Search Arena Academy. In my previous video, we take a look at nth motion, the way question is being set in JAB on nth motion, which I noticed that many students are not familiar with nth motion. That's why, based on my research, I need to make research on questions that are found under motion, likely questions that is set in motion in JAB. And students should familiarize yourself with this kind of questions. That's why I brought about that motion. Altogether, today I'm bringing about another new thing that I discovered. I noticed that some of the questions in JAM is in graphs. So they want to know if you really understand how to analyze graph. So they give you questions on graph, maybe in form of motion. Then they want you to analyze the graph to find the graph for the motion. Altogether. Now, before we start the class, I would like you to use some seconds to click on the subscribe button below. Just try to subscribe on my channel, and also don't forget to click on the like buttons and then share the video with your friend. I'm sure that it's going to be helpful for them if they are to write JAM and if they are not even writing JAM for next year 2023. Now let's start. Today we are going to be taking a look at motion graphs. Now you see, we can describe the motion of a body either by using analytical method or by making use of graphical method. Now, the analytical method of description of motion is talking about using the equations of uniform motion that we already understand, that V equals U plus AT, V square equals U square plus 2AS, and then S equals UT plus half AT square, and S equals U plus V all over 2 multiplied by time t. Now, these four equations are known as equations of uniform motion. We can use these four equations to describe motion, but the best thing is JAM is going to test your knowledge on the usage of these four equations, and also your knowledge will be tested on how to analyze graph. Now let's kick start. Now, how many types of graph can we have in physics? There are different kinds of graphs that we can have in physics. Let me try to use. There are some parameters that are very, very important in this place that I want you to know. The first thing that you need to see here is the velocity. The second thing is the acceleration. These two parameters are really important in motion. Now, when we talk about velocity, you said velocity is the change in displacement of the body, against time taken. While acceleration is the change in velocity of the body all over time taken. Now, what you should understand in any physics graphs are always following equations altogether. Now we can have a distance time graph in physics. Now, I'm going to be differentiating all of them for you. We can have displacement time graph, and we can have velocity time graph. Now, these three time graphs that we can have under motion, how do we understand this? Altogether, now when we talk about distance time graph, this thing is trying to tell you that a graph that is showcasing distance divided by time. Now, distance divided by time is going to give rise to speed. Altogether, it simply tells us that distance time graph can only be used to analyze the speed of a body. Altogether, now, we now have a displacement time graph. Now, taking a look back into this equation here, displacement over time indicates velocity. Now, displacement time graph can be used to analyze the velocity of a body. Please take note of all this because your knowledge will be tested on this. I'll try to break everything down for you so that you really understand what they are trying to say. Now, what about the last one is now the velocity time graph. This indicates velocity over time taken, which tells us about acceleration of a body. So velocity time graph contains a lot of things, a lot of information is found in the velocity time graph. But let's start it one by one. Now, if I have a graph of distance against time, what can I find from this graph? The only major question that is always asked under this is that what? Majorly, each of these graphs are straight line graphs. Please take note, they are straight line graphs. The graph might be starting from the origin, and origin is a point where two quantities meet each other. This is the origin, comma 0, altogether. So motion graphs are always a straight line graph. It might be starting from the origin, or it is starting from another point on the distance axis altogether that is different from the origin. So the graph can start from any of these points here. Take note of that. Now, what is this graph telling us? Don't forget I said a distance time graph can only indicate the speed of a body. Now, let me tell you something about a speed. It is impossible for you to have a uniform motion in physics. Altogether, motion cannot be uniform. It is impossible to have it. But assumption makes us to understand that there is uniform motion. So, uniformity simply means whenever you have a straight line in physics, straight line indicates that quantity is uniform. Altogether, it is what's uniform. Now, this straight line of a distance time graph indicates uniform speed. Altogether, so whenever you see a distance time graph and you have a straight line like this, it indicates uniform speed. Altogether. Now, what about that in a velocity time graph? Now, if I have a displacement time graph, don't forget that there is a difference between distance and displacement. What is the difference between these two quantities? The difference between them is that distance is a scalar quantity, while displacement is a vector quantity. You see, displacement will describe the magnitude of the body and also describe the direction in which the body is traveling. But distance can only be used to describe the magnitude. Talking about the size of the body, the size of the motion itself. That's what distance is trying to describe. So, if I have a displacement time graph, don't forget that displacement over time indicates velocity. It can also be a straight line. It is also a straight line graph. So in a displacement time graph, if I have a displacement against time, we have a straight line graph. This indicates uniform velocity. Now, I noticed that many students want to ask questions on this. Let me quickly analyze something here. Now, in a displacement time graph, uniform velocity indicates a straight line that is coming from either the origin or from any point on the displacement axis. Are we together with me like that? Now, I think I'm done with that. Now, the major one that is not there is not the velocity time graph. The velocity time graph has a lot of things in it. And you need to understand what is there. Why? Because velocity over time tells us about the acceleration of the body. What do you mean by the acceleration? As in how the body is moving. Is it moving fast or the body is moving slow? That is a function of acceleration. Altogether, now, if we can also describe acceleration of a body using a graph. How do we do the description? From here, as a velocity time graph is always in form of this manner. I have a velocity and then we have a time. The time graph can go along this direction, where I have this. Now, in I say it has a lot of things. Now, you notice that these graphs are different. Now, let me showcase something for you. In a velocity time graph, I combine three graphs here. I want to do break this graph down. Now, whenever you have a graph of this manner, but look at, please, before you analyze, take a look at what is being plotted on each other. If velocity and time is being plotted, I think I've been able to explain this. Now, velocity against time here, a graph that is a straight line from the origin or from any points on the velocity axis, are you getting something now? Along the positive direction indicates uniform acceleration. Uniform acceleration of the body. Are we together? Uniform acceleration. Now, if I have it in this manner, whereby we have it is coming downward, this one indicates that the body is increasing. And whenever the body is increasing in velocity, it simply means the body is accelerating. But when the body is decreasing in velocity, the body is only decelerating or retarding. Are you getting what I'm doing? Now, from here, if I have a velocity time graph, in a velocity time graph, a kind of a graph that is starting from maximum velocity axis, maximum velocity towards to the what maximum time here is indicating uniform deceleration. So this indicates uniform deceleration, or you can easily call this the uniform retardation. Altogether, that is the third part of it. See, I've been able to have 1, 2. Now, the last graph that you can see under velocity time graph, you can likely to see is whenever you see a graph of this is velocity against time, time taking, and I have something of this. Now, this is a what? A line that is parallel to the time axis. This indicates uniform velocity. What about uniform velocity? Simply means this indicates that the velocity of the body is constant. It is not changing. So, this is velocity axis. So it indicates that when a body is having a velocity of 5 meters per second, it keeps on moving with that same 5 meters per second when there is a change in time. Are you getting something now? So uniform velocity is when velocity is changing at equal interval. Are you getting? And there is a change in time. That is what we call uniform velocity. So here we are indicating that the body is moving with a uniform velocity. Now take note again. Let me give you this secret. Now there's one thing I want you to know. A body might be moving with a uniform acceleration. Are you getting? So whenever a body that is moving with a uniform velocity has an acceleration to be equal to 0. Are you getting? When the body is moving with a uniform velocity, then they said the body is moving with a uniform velocity simply means the acceleration of the body is 0. That means in this motion here, the acceleration of the body from here to here is equals to 0. Why? Because the body is moving with what? Uniform velocity. If you take back to what definition, acceleration is velocity minus u all over time. Now, what this thing indicates is that initial velocity u is 5. Final velocity v is also equals to what? 5. If I subtract this, I'll be having 5 minus 5 over time, which is equals to what? 0 over time, which is equals to 0. So, a body that is moving with a uniform velocity has a 0 acceleration. But a body can be moving with a uniform acceleration, and that body will have a velocity. Now, I think I've been able to break down this for you under that. Now, let's now take a look at this velocity time graph on its own, separately, before I move on. Okay, please take note of this. Now, what are the likely questions that we can see on a velocity time graph? How do we analyze a velocity time graph when it comes to what? Jump. That's what you need to know from here now. Now, take a look at this. This graph can be divided into what? Different area. I've been able to explain to you that majorly question that is always asked on velocity time graph in jump is either you are asked to find the acceleration of the body. You might be asked to find the total distance of the body. I'm going to be dropping a video link in my description box that tells where I explain the velocity time graph for you. Because today we are not going to be going into velocity time graph. If you need an explanation on that, just drop a comment for me. I'll surely share a link to you so that you can easily watch the video. Now let's move on to questions that are asked in JAM under this. How do they ask us questions on each of these velocity time graph, graphs in motions graph in general? Let's take a look at the question in JAM. I think I saw this question. I was like, okay, one day I'm going to use to explain to my students. Now, this is the question. They said, a stone thrown vertically upward returns to the ground. A stone thrown vertically upward returns to the ground. Okay, returns to the ground. Which of the following figures represent the velocity time graph? We are given a figure of this. I think I have this to indicate velocity, this to indicate time, and then I have something of this kind. Here is 2t. This is time axis. This is t. Now that is option A. Option B, I have something of this kind. And this is t, this is 2t, and this is my velocity, this is zero origin. Option C, I have something of this kind. I have, I'm going to be analyzing each of these for you. Now, option D, I have something of this kind. Where I have this, it crosses the x-axis, and then I have what's 2t. This is origin 0. Okay, now let's take a look at this. First of all, they said a stone is thrown vertically upward, returns to the ground. As soon as I have the stone to be here, then the stone is thrown upward, it returns back to the initial position in this place here. Now, let me try to analyze this motion for you so that you can understand what is there. Now, when you throw your body upward, the body is moving against the influence of gravity. Whenever a body is moving against the gravity, the body is said to be decelerating. Decelerating. Are you getting it? That means deceleration occurs when the body is moving upward. The body tends to decelerate. Why? Because it is against the gravitational what? Gravity. All together. Now, when the body is now, a time will reach in which when you throw a body upward, the body will be moving up until to get to its maximum height. At the maximum height of the body, this is the maximum height of the body, based on analysis. At this maximum height of the body, the final velocity of the body is equal to 0. Don't forget that the body is being thrown with an initial velocity of u. Now, what is happening is that because the body is moving up, that u started reducing. There is a reduction in velocity. There is a reduction in velocity until the body got to the what? Maximum height. So when the body got to the maximum height, the velocity of the body now turns to what? 0. Are you getting what now? And don't forget, if a body is moving and there is a reduction in velocity, it simply indicates the body is in deceleration. Deceleration. Are we together? Because it is in deceleration, it is when the body is decelerating, that is when the initial velocity of the body will be greater than the final velocity of the body. I think that is the first part of the motion. Are you getting what now? So I'm still trying to analyze this stone. They say the stone is thrown vertically upward. Don't forget it is going initially upward, it decelerates until it gets to its maximum height. When it comes to the maximum height, the body is now in position to drop down. Are you getting it? So when the body is dropping down from the maximum height, that body is moving in the same direction as gravity. When the body is not moving in the same direction as gravity, the body tends to accelerate. Why? Because in that case, its velocity now is 0. That final velocity before will now turn to its initial velocity. Then that body will now be moving with that velocity until to attain this same initial velocity back. On dropping to the ground, then the body is going to return back to its normal initial velocity that is used to throw it. So in this case, the body is kind of increasing its velocity. There is an increase in velocity. And when there is an increase in velocity, it indicates that the body is accelerating. Now, take a look at acceleration time graph. Now I said, whenever you have a graph of this manner, where it is velocity over time, this indicates the body is accelerating uniformly. When I have a body of this velocity time coming like this, it indicates the body is decelerating uniformly. Are you together? Now, the question that I gave to us, they said a stone is thrown vertically upward. Are you getting us now? A stone is thrown vertically upward, return to the ground, then if stone return to the ground. Now they said, which of the following figure represent velocity time graph? Now, let's take a look at this. This is velocity time graph, everything is velocity time graph. Now, normally this indicates this thing that is here from O to this point here, from option A, this is option A, this is option B, this is option C, this is option D. For option A, altogether, it indicates that when the body is going like this, the body is accelerating. And then, if you watch the motion itself, the body is thrown upward, which is decelerating initially. Then after, when it is now coming downward, it is now what? Accelerating. Then this cannot be the answer, because this one indicates that the body is accelerating initially. On getting to the maximum point, it was decelerate, which is impossible. This can only occur, you can only have this kind of graph when the body is falling freely. Maybe the body is on top of this building, this height here. The ball is now rolling downward. in this case here, the body is accelerating. On dropping to the ground, it is going to rebound. On rebounding, it is now what? Decelerating. Then I can have this graph. So this graph can be getting only when the body is dropping downward, whereby it accelerates. On getting to the ground, it then what? Decelerates. All together will be like that. Now, take a look at this option C here. A velocity time graph for uniform velocity. Hello, this is velocity against time. Please note, this indicates when the body is moving, in two-dimensional axis, whereby the body will be having two velocity, initial velocity u, it will have two initial velocity along the horizontal direction, and the initial velocity along the vertical, sorry there's nothing here, along the vertical direction, uy and ux. Are you getting me? We normally have this kind of graph here in projectile motion. All together, that is for this graph that is here. Now, you see this graph C that is here. This indicates that, look at this line coming downward, indicate that the body decelerates initially. Are you getting me now? When it gets to its maximum height, I said at maximum height, velocity of the body will be equal to 0. If I trace this thing here, this indicates the velocity is 0. So when it gets to the maximum height, are you getting what I'm saying? Then the body starts dropping, and starting to drop, it tends to accelerate. Are you getting what I'm saying now? So my correct answer is option B. Now, option D here only indicates that the body is decelerating. Are you getting what I'm saying now? It is decelerating, no acceleration. But according to that motion, the body decelerates at the same time to accelerate. So my answer to this is B. Now, I noticed that these questions are common in JAM. That's why I need to come today to explain to you how we can analyze graph in physics. Now, I think I have another graph that is here. Okay. It said velocity time graph of a body moving in a straight line and decelerating uniformly to rest is represented. Look at the question. I have this velocity. I have this. I have this. And I have this. They said the velocity time graph of a body, please note that everything is velocity time. Velocity time, velocity time, velocity and time. The velocity time graph of a body moving in a straight line and decelerating uniformly to rest is represented by. How do we represent the velocity time graph here? Now, the body is moving uniformly and decelerating to rest. Don't forget that this one is not a uniform motion because they said the body is moving uniformly. This might be a velocity. This graph here only indicates instantaneous. Are you getting something? Instantaneous velocity of the body. Instantaneous acceleration. Are you getting something? Hope you're with me. This indicates instantaneous acceleration. We are about to be having a point where the line coincides. Are you getting me? The same thing applies to this. It is instantaneous. But here, so this instantaneous, they are non-uniform velocity time graph. Now, it is only these two graphs, graph C and graph D, that indicates uniformity. That is the first statement. The second statement now indicates that the body is decelerating to rest. This one indicates that the body is accelerating, while this one indicating that the body is decelerating to rest. So my option is option C. All together. So I think that is how they set question on this. So I would advise students to keep note on this. Anything that you don't really understand about this graph, just drop a comment to me for me. I'll surely attend to your comment on this and I will explain it to you more better. Thank you for watching today's video. Please don't forget to click on the subscribe button to subscribe to my channel. And also share the video with your friends and click on the like button, please. That is very, very important. Are you getting now? The like that you give to my video will make YouTube to share the videos, to share the video across their to share the videos to people to watch, to show that that content is really helpful. Please. Thanks so much.